In this video, we're going to be looking at a bankruptcy classification scoring metric. And so this metric was developed from a study done by Edward Altman and published in the Journal of Finance in 1968. So it's quite an old measure, but one that's still often used in academic research, particularly in finance and accounting. And the idea in this study was Altman wanted to examine whether or not there were publicly available financial statement metrics that could be used for all companies to evaluate the likelihood that that particular company would go bankrupt. The goal was to use information that was easy to get your hands on so that you could apply this measure pretty easily to any company. So if you were to open up this paper and scroll through and look through all the tables, you would come to the details of Altman's calculation. So Altman's z-score, which is a metric to predict the likelihood of bankruptcy for a company, is a parsimonious model, so it doesn't use much data. It doesn't require much data. It uses 5 financial metrics or ratios that can be calculated with readily available data. And so you take 1.2 and multiply it by the x1 factor and all the way through to the 5th factor, right? So it's a linear transformation of some financial statement ratios. So what are these ratios? Well, x1 represents working capital divided by assets. So this measures liquidity. We also have measures for long-term profitability, short-term profitability, long-term solvency, and asset efficiency. So the idea here is in this lab to collect some data on some of these financial statement metrics, transform those metrics using the formula for the Altman z-score, and then evaluate the likelihood of any company in our data going bankrupt. Okay. All right. So let's hop over to the Excel file now. All right. And so in this lab, I have already assembled the data here for calculating the Altman Z. You can see we have GB key. This is a unique identifier corresponding to each publicly traded company. This is assigned by a data service called CompuStat. We also have a field for the company name. We have the fiscal year. This is current assets, so ACT stands for current assets in the CompuStat data, which is our data source. AT is assets. EBIT, as you would suspect, is earnings before interest and tax. We have short-term liabilities, long-term liabilities, net income, retained earnings, sales, and I believe ME is the market value of equity. All right. So our job here is to take this data, create the Altman z-score. All right. So the first thing we need to do is create these 5 variables: x1, x2, x3, x4, and x5. All right, so if we come back over to our calculation here, so x1 is short-term assets divided by total assets. Okay, so if we come back here, we can take current assets divided by total assets. We're going to say current assets divided by total assets. Okay, and then the x2 factor is retained earnings divided by total assets. So we're going to say retained earnings divided by total assets. Okay. And don't worry about the scale of these variables yet. We'll talk about that in just a second. X3 is earnings before interest and taxes divided by total assets. So if we come back, we're going to say EBIT divided by total assets. The 4th variable here is market value of equity divided by book value of total debt. Okay, so we're going to take the market value of equity, which is this number, divided by total debt, which will proxy with total long-term debt. All right, and then the last variable here is sales divided by total assets. Okay, so if we come back, we're going to say sales divided by total assets. Okay. All right, so now we've constructed our 5 factors here. Now, if you wanted to, consider the meaning for each of these numbers. So working capital to total assets, this is kind of like a percentage based variable. So you can think about these maybe in terms of percentages. So their working capital is 35% of total assets. If we think about the second factor here, we have retained earnings to total assets. I don't know if there's an intuitive interpretation that would be useful here. Earnings before interest and tax and total assets. So this is kind of like a scaled profitability measure. It's 10%. And then X4 is market value of equity divided by the amount of debt owed to measure the company's capital structure. And then X5 here is sales to total assets. Again, another efficiency measure. All right, so we have these variables set up. You can, create these. You could format these as percentages if that's helpful for you. You can format these as just raw numbers. It doesn't really matter for our purposes here. So what we're trying to do is create a z-score, and this Altman z-score is going to be equal to, if we come back, it's going to be 1.2. We can actually just copy this, right? So we'll go back to Excel here, and we're going to say this is equal to 1.2 times x1. So x1 we want to replace with our field here, x1, and then we want to replace x2 with our cell that contains x2. And then we're just going to continue this for each factor in this calculation. So this gives us our Altman z-score, okay? And now that we've constructed this, we can actually just copy this all the way down to the end of the table here. And if you scroll all the way down, it looks like we successfully copied this. And now we have an Altman Z for all of these. Okay, so if we come back here, the Altman Z-score is calculated as this. All right, so the way that the Altman Z-score works is that generally the lower the value of the metric, the lower the Z-score, the more distressed a company is. All right, so let's think about this here, and what I'm going to do is I'm just going to select all of this entire table that we've set up here, and I'm going to sort it. So I'm going to say data, and I'm going to sort, and I'm going to sort by the Altman Z-score, and we want to go smallest to largest, because what we're looking for here is the companies with the lowest score, which would indicate that they are in distress. Right, so some of the some of these are negative, which is not a very good sign. And so if we think about, if we kind of look through here, like Krispy Kreme donuts in 2008, right? And so what I'm doing now is I'm just trying to make sense of whether or not this Z-score kind of matches reality. And so in 2008, Krispy Kreme had a very low Altman Z-score. Okay, so what we want to do is we want to just validate this measure. We want to, not in a rigorous way, but we want to see if this measure makes sense, right? So Krispy Kreme is a household name. It's a company that's pretty known. And what we want to see is if we look through the news in 2008, were there any signs that Krispy Kreme was experiencing some issues with its financial health? All right, so I'm just going to Google Krispy Kreme financial health 2008. All right, so just a simple search. All right, let's see what we get. So Google's AI Labs here is indicating in 2008, Krispy Kreme was facing significant financial challenges and struggling with the turnaround effort. So they had poor performance and losses, declining revenue, franchisee problems, high debt, and credit issues. This is probably the one that kind of fits with what we're seeing in bankruptcy predictions. So this AI result that was given to us by Google, it links to sources for each of the statements. So if we wanted to, we can follow these links and kind of see where AI is getting its information. So this is right from a Krispy Kreme SEC filing. In 2007, secured credit facilities contained significant financial and other covenants. Based on its operating plan, the company projected that it would not be able to comply with financial covenants in fiscal 2009. All right, so it kind of lines up. So one of the companies that we've identified with a low Altman Z, which would indicate financial distress, was Krispy Kreme Donuts. And then when we try to validate or see if this measure makes sense or if that value makes sense, we're seeing indications that, yeah, it does. Krispy Kreme was going through some difficult financial times in 2008.